Okay, welcome back to the discussion for 1.5 and 1.6. Had a couple of questions on 1.5, so we'll jump in there. Let's start with number 3, which I've written on the board. The second angle of a triangle is 10 more than twice the first, and the third is 30 less than the first. Find these angles. So I would start by just drawing a triangle. Again, it doesn't have to necessarily be accurate. We're just looking for a triangle. I'm just going to name these angle 1, angle 2, and angle 3. And in our problem it says that the second angle, so this one, of a triangle is 10 more than twice the first. So since it refers to the first, I'm going to call the first x. And then the expression for the second one is 10 more than twice the first. So that is to say 2x plus 10, because that is 10 more than twice the first. That is to take twice the first and add 10 to it. I can create an expression for my third one. The third one is 30 degrees less than the first. Well, that's just that first one, which is x, and then minus 30. And those are my three angles. Right? Now, I also need to know that the sum of these three angles is going to be 180, and that creates my equation. So angle 1 is x, plus angle 2, which is 2x plus 10, plus angle 3, which is x minus 30, equals 180. And I have an equation. So I can simplify this. On the left-hand side, I have x plus 2 more plus another one, so that's 4x altogether. Then I have plus 10 minus 30, that's minus 20. And that equals 180. I'm going to get the 20 off of the left-hand side by adding it to both sides. That leaves me with 4x equals 160. And divide by 4 gives me x equals 40. So that doesn't answer the whole question, that just solves what x is. The answer to the question is angle 1, which is just x, is 40. Angle 2 is 2x plus 10, so 2 times, well, x, which was 40, and then plus 10. And so that's 80 plus 10, and that's 90. And then angle 3 is x minus 30, that's 40 minus 30, so that's 10. And those are my three angles. Angle 1 specifically is 40, angle 2 is 90, angle 3 is 10. Let's look at number 4. 4 says a board initially 48 inches long is cut into two. The longer piece is to be 3 inches longer. Three inches longer than twice the smaller piece. And then we're asked to find out the length of each piece. Right? So we're going to draw a picture just to see visually what's happening. I have a board. I know that the board is 48 inches in length until it is cut into a smaller piece and a larger piece. Right? the larger piece is defined by the smaller piece, so I'm going to call this smaller piece x. And then the larger piece is to be 3 inches longer than twice the smaller. So that is 3 more than twice the smaller. 2x plus 3. Right? And I want to figure out the size of both pieces. So what I do know is that this x and this 2x plus 3, when they combine, they make up the whole board, and that gives me my equation, is that x plus 2x plus 3 should be the whole 48 inches. Right? We're going to ignore for a moment that there's a cut and you lose a little bit of the board. Right? Let's not worry about that right now. If I solve this, I can combine my x and 2x. That gives me 3x plus 3 equals 48. Subtract 3 from both sides. That gives me 3x equals 45. And if you divide each side by 3, I think you can see here, we're going to get x equals 15. Which tells me that this piece, the smaller piece which is x, is 15. The bigger one is 2x plus 3, so it's twice 15, which is 30, plus 3 more, so it's 33. And those are our pieces. Okay, let's look at number 6. 6 says, solve the problem by first writing an equation and then describing it. Or, sorry, that describes it. I can't read. It says then the sum of 3 consecutive odd integers. Odd integers is 51. And then they want us to find these integers. And we saw a problem before where we just had the consecutive integers, which meant we had like x and x plus 1 and x plus 2, because they were all 1 apart. And even if you have odd integers, right, say 3, 5, 7, 9, 11, these numbers are all 2 apart, right? And so if I have some unknown and it's an odd integer, the next integer that's odd is still 2 apart. It's 2 away, so it's x plus 2. The next one after that is x plus 4, right? This 2 represents the distance between these numbers. 3 to 5 is 2 away. Add 2 more, you get 7. Add 2 more, you get 9, right? So these are my integers. X is odd, and if x is odd, x plus 2 is odd, and x plus 4 is odd, and they're consecutive odd, right? That's what I want, and I want those 3 things to add up to. So I want plus that. This has to add up to 51. So I have 1, 2, 3 x's here, plus, and then 2 and 4 is plus 6, equals 51. Subtract 6 from both sides. I'm going to take this up here. If I subtract 6 from both sides, I still have the 3x on the left. The plus 6 and the minus 6 go away, and then I end up with 45. Divide each side by 3, and I have x equals 15. And that's my first odd integer, and therefore my 3 integers are x was 15, x plus 2 is 17, and then of course x plus 4 is 19. Those are indeed consecutive odd integers, and if I add them up, I get 51. okay with that? Then the next question I had was number 8. The number 8 is similar to this one. Let's take a look at it. Eight has 5 consecutive even integers. Is 70. Right. So those consecutive even integers, even numbers are also 2 apart, right? Pick a spot, 6, let's say, that's an even integer. The next integer after that is 2 more. So if I start somewhere, doesn't matter where, the next guy that I get is 2 more. The next one I get is then x plus 4. In this case I have 5, so there's 1, 2, 3. The next one after x plus 4 is 2 more than that, so x plus 6. That's my 4th, and then x plus 8. 1, 2, 3, 4, 5. Those are my 5 integers, and the sum of those should be 70. So I'm going to erase this, just to give myself some space to work here. That means then x plus, the next one is x plus 2, plus the next one is x plus 4, and then x plus 6, and then x plus 8. That equals 70. I've got 1, 2, 3, 4, 5 x's, plus 2 plus 4 is 6, plus 6 is 12, plus 8 is 20. Subtract 20 from both sides. I've got 5x equals 50. Divide each side by 5, and x equals 10. Right? And that's my first number then, right? The very first number here, x is 10, x plus 2, 12, 14, 16, 18. If you add those up, 1, 2, 3, 4, and that's 70. That was it for 1.5. Let's take a look at 1.6. There was only one question in 1.6 that was asked of me in both of my classes, and that was number 12. And it says, y varies inversely with the square of x. So we've got this inverse relationship. But we've also got this that we haven't seen, the square of x. Right? And then we're told if y is 8 when x is 2, then find y when x is 4. So because it's an inverse, that means that I have this equation. Okay, divided by, but it's not just x anymore, it's inversely proportional to the square of x. And therefore my denominator down here is the square of x, right? Now we haven't seen this, it was kind of like a surprise, like they may have mentioned it I don't recall. It may be the first time you've seen this, but that square of x, right? It's not just an x down here anymore. But I can still go through the problem and solve it just like we did before. Y is 8. When x is 2, tells me that 8 equals k over 2 squared. But that means that 8 equals k over 4. So I can multiply both sides by 4, and I find here that k is 32. So then I have that this equation turns into y equals k, which is 32, over x squared. And they want to know what y is when x is 4. So I'll plug in y equals 32 divided by 4 squared. 4 squared is 16, so I have 32 divided by 16, and that is 2. So it is a bit tricky. It kind of came out of nowhere, I feel like, but it's still similar. We just have this x squared in the denominator instead. All right, thank you, and keep it up with the discussion boards. Remember, you can answer questions in there too, but make sure that your name gets in there somehow. And I'll see you for the next one.